Good morning, friends. Myself, Devdi P from 3rd DC Chemistry. So, as a part of assignment, today I'm going to deal with two questions from the chapter Orthogonal Functions and Fourier series. So, let's discuss. I'm going to discuss the questions from page 240, question number 8 and question number 9. So, let's start with question number 8. So I'm going to read the question first. Show that the given set of functions is orthogonal on the indicated interval and find the norm of each function in the set. So the first question is sin nx, where n is equal to 1, 2, 3, etc. And the interval given is from open interval 0 to pi. So let me take the slide first. So here let's take phi n of x is equal to sin nx, where n is equal to 1, 2, 3, etc. Then phi m of x is equal to sin mx, where m is equal to 1, 2, 3, etc. So to find the orthogonality, we can take phi m comma phi n is equal to 0. We need to prove this is equal to 0. So for that, phi n comma phi m is equal to integral 0 to pi, where we need to prove that this function is orthogonal in this given intervals, open interval 0 to pi. So from integral 0 to pi, phi n of x into phi m of x dx. That is, we have taken phi n of x is equal to sin nx and phi m of x is equal to sin mx. So substituting, we get integral 0 to pi sin nx into sin mx dx. We know that sin a into sin b is equal to 1 by 2 into cos a minus b minus cos a plus b. So we need to substitute this in the equation for sin a into sin b. Thus we get phi n comma phi m is equal to 1 by 2 integral 0 to pi cos nx minus mx minus cos nx plus mx, which is equal to half integral 0 to pi. We can put the common x outside. So cos n minus mx minus cos n plus mx, which is equal to 1 by 2 into sin n minus x n minus m into x by n minus m minus sin n plus m into x by n plus m from 0 to pi. We have integrated. So while substituting from 0 to pi, we get half into 0, which is 0. Hence we prove that the function is orthogonal. That was our task. For proving the orthogonality, we need to prove that phi n comma phi m is equal to 0. Thus we have proved. Thus we get sin nx comma sin mx is equal to 0 for all n not equal to m, which is m is equal to n is equal to from 1, 2, 3, etc. n times in the interval open interval 0 to pi. Hence we have proved that the function sin nx is orthogonal on the interval from open interval 0 to pi. The next part of the question is to find the norm. So to find the norm, we know norm phi n of x whole square is equal to integral a to b phi n square of x into dx. Here we need to take the phi n is equal to sin nx. Phi n of x is equal to sin x. So substituting in the equation, we get norm phi n of x whole square is equal to integral 0 to pi sin square nx dx. We know that sin square nx is equal to 1 minus cos 2x by 2. So substituting in the equation for sin square x, we get integral 0 to pi 1 minus cos 2nx by 2 into dx. So while integrating, we get 1 by 2 x minus sin 2nx by 2n from 0 to pi. So by substituting from 0 to pi, we get the answer as pi by 2. Here we know phi n x of whole square, that is norm phi n x of whole square is pi by 2. So the norm phi n of x is equal to root of pi by 2. Similarly, we have the next question, that is the ninth question. We need to prove in the similar way. So the ninth question is sin n pi by p of x. We need to prove that sin n pi by p of x is orthogonal, and we need to find the norm for this function from n is equal to 1, 2, 3, etc. n times, and the interval is open interval 0 to p. So similar way, we need to consider two functions, that is phi n of x is equal to sin n pi by p of x, where n is equal to 1, 2, 3, etc. Similarly, phi m of x is equal to sin m pi by p into x, where m is equal to 1, 2, 3, etc. So we need to prove the orthogonality. So phi n comma phi m is equal to integral 0 to p phi n of x into phi m of x dx. Substituting, we get 0 to p sin n pi by p of x into sin m pi by p of x into dx. In the similar way, we know sin a into sin b is equal to half into cos a plus a minus b minus cos a plus b. Once again, sin a into sin b is equal to half of cos a minus b minus cos of a plus b. So we can substitute. Thus we get, we can put half outside because half is a constant. So half into integral 0 to p cos n pi by p of x, n pi by p into x minus m pi by p into x minus cos n pi by p into x plus m pi by p into x dx. So next is half into integral 0 to p. We can put the common pi x by p outside. So we get cos n minus m into pi x by p minus cos n plus m into pi x by p into dx. So integrating, we get half into sin n minus p into pi x by p divided by n minus m into pi by p minus sin n plus m into pi x by p whole divided by n plus m into pi minus pi by p from 0 to p. Interval is from 0 to p. So after doing all the, that is substituting, we get half into, we can put, instead of x we can put p, so that the p from numerator and denominator will be cancelled, and we get sin pi into n minus p. We know sin pi times of n minus m is actually 0. So we get the whole thing in the bracket as 0. So we so the answer will be 0. Half into 0 is 0. Hence we prove that this given function is orthogonal. Thus we get sin n pi by p into x comma sin m pi by p into x is 0 for all n not equal to m, where m is equal to n is equal to 1, 2, 3, etc. n times in the interval open interval 0 p. Hence the function sin n pi by p into x is orthogonal on the interval open interval 0 to p. The next part of the question is to find the norm. In the similar way, we can put we can consider the function as phi n, that is phi n is equal to sin n pi by p into x, and the given interval is 0, p. So to find the norm phi n of x whole square is equal to integral 0 to p phi n square x dx. So substituting the phi n, we get integral 0 to p sin square n pi by p x dx. So we know that sin square x is equal to 1 minus cos 2x by 2. Hence substituting, we get 0 to p 1 minus cos 2n pi by p into x by whole divided by 2. Putting 1 by 2 outside, we get half into integral 0 to p 1 minus cos 2n pi x by p. Now integrating, we get half into x minus sine 2n pi x by p divided by 2n pi by p. Substituting from 0 to p, we get half into p minus 0 minus 0 minus 0 by substituting from 0 to p. Hence the answer is p by 2. Norm phi n x of whole square is p by 2. Hence norm phi n x is equal to root of pi by 2. So I think it's clear to you, and this is the end of my topic. Thank you.